just to recap, so we graph this function, and then we switch the domain and range to get the inverses points. The inverse function. I'm going to call her running man. So now we're going to go to the square function and check out its inverse graph. So in a similar fashion, after I do the squared table to find my inverse table, I can quickly just reverse the table. The inputs now become my outputs. My outputs now become my inputs. So I'm going to graph them on the same axes. So this technically does not match what we did here. I didn't include my plus or minus symbol. The square root function stemming from a squared function actually becomes two functions, a positive root x and a negative root x. So this table is technically, I shouldn't have called it y, this table technically reflects a positive root x and a negative root x t-chart. So we need a little discussion about domain and range, especially since we would never graph this at the same time unless both the positive and negative are listed. But when you're going to be given a lot of problems that just say root x. It just says graph y equals square root of x. So it's only concentrating on the positive square root of x. So that's only this arm. I'm going to highlight. It's only this half of the arm. So today's functions and tomorrow's functions, we won't be able to finish it all, is going to concentrate on just this piece of the inverse. Which, kind of like yesterday when we discussed these sort of functions, there would always be like a comma. X needs to be something with 0, like greater than or equal to, less than or equal to. There had to be a restriction on what we were concentrating on. So, because I did not give you a restriction in the beginning, we didn't get one in the end. So just know, today we're going to look at half of arms. So, we're doing section 7.5. We're going to talk about graphing square roots and cube root functions. This is also in your textbook, by the way. So if for some reason you lose your notes, all these transformations are in your textbook. We're really going to concentrate on the top 4. Top 4 are definitely what you use all the time when you leave me. So to recap, if I'm comparing these two functions, dealing with the square root, how does this get adjusted? It's a vertical shift, moving up 3. In this next example, if I'm comparing this function to the original cubed root, there's a 5 being added on to the inputs inside. So it's a horizontal shift, left 5. So let's try these. These next ones, we're going to compare this next one to the square root of x, or to the square root function. We've got that vertical shift moving down 4, and then we've got that horizontal shift inside moving right 1. Then we've got the next function that we're going to compare to the cubed root. So what's going on here? What's affecting the inputs? What's affecting the outputs? The 6 is going to affect the outputs. So the 1 affects the inputs, the 6 affects the outputs. This is going to be the function that we're going to compute. This is going to be the table that we use for number 6, number 7, number 8's function. So we're going to develop a table. We're going to plug in some nice square root numbers. So, plugging in nice inputs. And graph. So we're going to use this table now as our main function. 4 root x, what's happening? That's what we're going to be asking ourselves. Do the inputs change? Because if the inputs change, I'll change my x column. If the outputs change, I'll change my output column. Y equals 4 times the quantity, the square root of the quantity, x plus 3. We're going to use that old table. After I copy down the old t-chart, now I'm going to try to figure out what is being affected, the inputs or the outputs. So now that we realize it's the inputs that are being affected, we're either moving right or left. So if I go back to that table in my notes, whenever I have something affecting the x in parentheses, and not only that, but we have a nice cheat sheet that says f of the quantity, x plus c, it says that it's going to move left so many units. So this plus 3 means you're moving left 3. That means I'm going to subtract 3 from all of my inputs. My outputs do not change. It's my inputs that are only subtracting 3. So my old input of 0 now becomes negative 3. My old input of 1 now becomes negative 2. My old input of 4 now becomes 1. I realize my numbers aren't lining up here. These are going to be my new points and graph it. So next problem. We're going to take that 4 root x table again and then figure out what that minus 5 does. You need to determine, is that minus 5 within the function or outside of the function? Is it within the square root or is it outside of the square root? It affects the outputs because it's outside of that square root. So I'm actually going to move all outputs down 5. I'm going to copy down that chart again and then show the shift within the new t-chart. All outputs subtract 5. Tomorrow we will start here.